Hi guys, I'm going to try to help you here with a little bit of Renaissance objective examples. So when we're working with systems of linear equations, you already know that if you have two equations with different slopes, those two lines are going to intersect like these. And then in that case, the system will have one solution. If you have two equations that have the same slope, but they're not the same line because they have different y-intercepts, then you're going to have lines that are parallel. So equations with the same slope that aren't the same equation are parallel lines, and that means they have no solution. The system has no solution. And then finally, if the two equations are identical when you reduce them, then they're the same exact line, and so they would share infinitely many solutions. So here's a few examples that show up in Renaissance. Let's call this problem 1. You notice the equations are always in slope-intercept form so that we can see the slope and the y-intercept. So in these cases, we have to solve them for y first before we can tell what we've got. So in this case, I would not do anything until I cleared this fraction. So first I'm going to multiply by 2 to every single term so that this fraction cancels out. This would give me 8x, this would give me 3y, and this would give me 4. Now it's really easy to solve for y. So I'll get my 8x on the other side by subtracting it so it cancels. Then I will have negative 8x plus 4. Then I'll divide everything by 3. And so this equation finally looks like y equals negative 8/3 x plus 4/3. So here's the slope for this line. So I'll keep that in mind while I look at the other one and see what I've got. So I've got another one where I need to clear a fraction. So we'll just handle it. If I bring this down here, to clear this fraction, I guess I need to multiply everything by 3. When I do that, this one will cancel out, and so will this one. So I'll have negative 6x when I multiply those, plus 4y equals 8. So then I'll have to add 6x to both sides to get y by itself here. 4y equals 6x plus 8. And then I'll divide by 4 to everything. Now this one, I'll have to reduce. I've got y equals 6 over 4x, and 8 divided by 4 is 2. Now if I leave it like this, I'm going to think that these two lines have different slopes, and they might very well have different slopes. But I want to get in the habit of reducing this fraction if I can. 6 and 4 are both even numbers, so I can divide them by 2, and that would give me 3 over 2. 2 goes into 6 3 times, 2 goes into 4 2 times. So I'd have y equals 3/2 x plus 2 for my final version. And if I compare the slopes then, this equation has a slope of 3/2, and this one is negative 8/3. Those are not the same. So if lines have two different slopes, they will intersect. And then how many solutions will they have? One solution. So the question will be A, and the choices will be A, one solution, B, no solution, 3, infinite solutions. This one, if they have different slopes, they're going to cross, so they have one solution. Here's another example. This one, all I'd have to do is subtract 6x, so I'd have 8y equals negative 6x plus 39. And then I just divide everything by the 8. Look, there's one that's going to have to reduce. They're both even. So if I divide 2 into both of those, I get negative 3x, and 2 goes into 8 4 times. These 8 doesn't fit into 39 evenly, so we'll just keep it as a fraction. So there's that one with a slope of negative 3/4. Now let's take a look at the other one here. We'll multiply everything by 3 to get rid of that fraction. And then I'd have 6x plus 8y equals 3 times 13 is 39. Then I'm going to minus 6x from both sides. And you might start to notice something. 8y equals negative 6x plus 39. Look what I've got here. Does that look familiar? When I divide everything by 8, I'm going to have the exact same equation. So that reduces to negative 3/4. And this one doesn't divide or reduce. So there we go. Not only do they have the same slope, but they're the exact entire whole matching equation. So this would have infinite number of solutions. Infinitely many or infinite solutions. So these first two are sort of worst case scenario. It won't get much worse than that. Here's a couple that are pretty easy. So just to remind you how to get y by itself, be careful with signs. When you're getting x on the right side, you need to add, since it was negative x, we have to add it to make it cancel out. So over here it's going to come out positive. So 9y equals x plus 20. Divide by 9 to every term. Now some people might not, oops, that's a 9, not a g, might not recognize that what the slope is here, this is invisible 1. So your slope is 1 over 9. And your y-intercept is 20 over 9. That doesn't divide. So there's that equation. This one, all we have to do to get y by itself is divide. The x is already on the other side. So y equals 2 over 18. Those are both even, so they reduce. If we divide them both by 2, 2 divided by 2 is 1. 18 divided by 2 is 9. So I get 1/9 x. Now I'll look at my equations. Here's the slope of this one. Here's the slope of this one. They're the same, but they're not the exact same line. They just have the same slope. So then you have to ask yourself, what kind of lines do I have? Hopefully you say parallel, since they have the same slope. And then you would choose no solution. Since the lines are parallel, the system will have no solution. And in this case, right there you already see the slope on that one. So that's a gift, negative 11. Let's see. To get this y by itself, it's on the other side. It's than where I'm used to it, but that's okay. If I add 16x to both sides, then I get rid of that one. So I'd have 16x plus 123 equals 41y. And if I don't like it this way and I want them rearranged, I can say 41y equals 16x plus 123. It doesn't matter if you want to call this side the right and this the left, or this the left, this the right, as long as you don't change any signs from what they were. So dividing everything by 41, look, this is a big mess for sure, but what I do know is that no matter what I do, if I reduce this or don't, 16 over 41 is not going to be 11 or negative 11. 41 cannot fit into 16 11 times, and besides this is positive and that's negative. So these are different slopes. What will those lines do? They will be intersecting. So if the slopes are different, the lines will cross. How many solutions? One solution, right where the lines cross. That's about it. I think you can take it from here. I really do. Good luck. Remember, you have to get 5 out of 6 right in order to be allowed to test. And then you have to get 4 out of 5 on your test to get this mastered. You can do it.